So, so what we have here to now is, yeah, actually I was doing this on Jocelyn's demand, right, Jocelyn? Okay. So he wanted us to, work on something with this, and I don't want to talk about, this like this forcing function and these two impulse forcing in a practical sense. No, just a textbook differential equation, and we are, at the moment, that's what we are doing. We are simply solving it. All right, everybody good? So here we go. So we have, so, I mean, this part you can get a complementary function, but in this case, since we got this direct delta here, okay, everybody clear? It will be a good idea to do what? Somebody, anybody? Go ahead. It will be a good idea to, how do we start this? Take the Laplace. Thank you, Daniel. Very kind of you. Okay, now very quickly, let me just search for Laplace here. And the operator here. Okay, there we go. Good. All right. So we will take the Laplace. Daniel, good suggestion. So let's go with that. So we got Laplace of this. Okay, and make sure that we are simply just mostly understanding the procedure, because the transcript, as well as since we are making video also, okay, so transcript as well as the video will be available on our website. Okay, all right, so here we go. All right, so then we have Laplace of who? E to the t. Okay, then plus Laplace of who? This direct delta at 2. And then we got what? Sorry about that. And then we got this forcing at 4. Everybody good so far? Medic? Good. Okay. So we know this. Let's just write the things that we know. Who this will be, if you, we computed it, or you can look at your chart, and this will be who? 1 over s minus 1, you meant, right? Okay, that's okay, because here the coefficient is 1, okay, and this will be who? E to the negative 2s, or s2 is fine as well, okay, 2s, okay, very nice. Okay, Jocelyn, your question, how does it look so far, sir? Okay, so David, just pay attention now on, we'll be good, sir. Okay. All right. So, oh, we have Rodney here. That's very nice. Okay, then we have e to the negative 4s. Everybody good so far? Right. Now, this one we have worked with so much that we know this. That is who that is? S Laplace of y, right? Very good. Minus y at 0, right, Alex? Very good. Thanks, Alex. Right. Okay. Yeah, right from there. Good. And then when I have to get the Laplace of the second derivative, what would I do? I'll just go to the one lower, right? And when I go to the one lower, what happens? I have the derivative of y prime here, so I can write y prime, right? Everybody good? And I can write a y prime here as well, right? Ralph? Raphael? Am I going too fast, sir?
Isn't it s squared?
Oh, we will get it at a square, because you have that also in your memory, and I don't, Raphael, but you're right. We will have s squared here, okay? Because, okay. But I'm just working it out.
Oh, yeah.
Okay, very good, thanks. So we will get s squared then. Actually, yeah, there is a relief because these guys are 0. But anyway, since we wrote it all, we will, we will write it at the end. Okay, here is your s square. then we'll get an S here. All right, and when we apply the initial conditions, all these guys will be out anyways, right? Everybody good so far? Good, very good. Okay, so we have all that. So let's write this down. So in this case, what will be? We got this, right? Everybody fine on this? Okay, and for this one, what we have, since y0 is 0, we could have used it before, but we forgot. No big deal. This is S of that, right? So far so good, everybody? Okay, thank you. All right, so when we look at this whole thing, okay, who is this? S square of that, right? And this would be 7s ly, right? Everybody clear? Okay, and then this we just got with Daniel's help. What was that? 1 over s minus 1. This is e to the negative 2s, right? And who is this guy? E to the negative 4s. Tell me, how do we look so far? Alex? Kareem? Are we caught up here? Okay. All right, Troya. Everybody fine, okay? Right? Rodney, sir. Oh, just, okay, let's see this here. I have an equation now for the Laplace transform, right, right, Rodney? So from this point on, yeah, I mean, I know you were held up somewhere. That is, why don't you help me get the inverse Laplace transform, right? Okay? And then we will look at all that later, okay? All right? So here I have s squared minus 7s plus 6. Okay. Now let's give one task to Jocelyn because he gave us these problems. Jocelyn, can you factor this thing for us? Who are the roots of this guy? 1 and 6. Very good. Everybody agrees with Jocelyn here? So that we got s minus 1 and then s minus 6, right? Okay. And then we got all this here, right? Everybody fine? Okay. So then we have Ly, right? Here what shall we have? 1 over s minus 1. When combines with this s minus 1, what will that get? S minus 1 squared, right? Everybody good? Then I have 1 over s minus 6, and then we got what? E to the negative 2s, right? Over this, right? Then plus e to the negative 4, very good, 4s over this, right? All right, now it's going to be just recognizing the symbols and doing algebra, isn't it, right? Everybody fine? Okay, so what we have to do, we have to get the partial fractions, right? Okay, that is, we have this. Let's do this one. All right, okay. I can just write this e to the negative 2s in this place. Okay, and then everybody good here? Okay. Now I'm just going to write the these guys, the partial fractions here automatically are okay, but all of you can work with patience, observation, and whichever way you can get it. If not, just have me do it at the end of the class for you. Okay, Everybody fine? But right now I'm just going to do it automatically. Okay. So we will go for partial fractions. Okay. We got that for this one, and in this one, it goes like a over s minus 1 plus b over s minus 1 square. That's a very good review of your, where is this? So we got all these guys, right? Everybody fine? So now we are ready to write the inverse Laplace transform, right? Okay, all right. Yeah, this is really a good question, Jocelyn. Very nice. Okay, okay. So what we have, our y will be, okay, our y will be what? The inverse Laplace of this quantity, right? Okay, Jason. Okay, and then what we have, then we simply got inverse Laplace of this quantity here, right? And then we got, and oops, sorry about that. And then we have inverse Laplace of this right here. Okay, everybody fine? Okay, and if we use the partial fractions that we got, okay, then this is what? This is this, right? Everybody okay? I'm just talking to the monitor here. Everybody fine on this, right?
Can you help me with the partial fractions part?
Indeed, I will. I sure will. Okay?
Okay.
I promise.
I mean, the regular one is no problem, but the s minus 1 squared.
Okay, sure. Yeah, we will do that. Just give me a moment. Definitely, definitely. Okay. And then here what I have is, okay, yeah, sure. Just give me a few seconds. And then we got these guys, right? Okay. All right. And then we got who? Again, these guys, right? Okay. So what I'm going to do is I'm going to pause this, our recording, in a way that we will now look at our glossary of Laplace transforms and then recognize the inverse Laplaces. All right, everybody fine? So give me a second. So here, sorry. So let's do this here. So when I look at this, so remember we know this, that the Laplace of e to the alpha t, okay, is what? 1 over, excuse me, 1 over s minus who? Alpha. So when I look at this, who this will become then? Help? Somebody, anybody help? E to the 60. Very well said. Okay. So this is e to the 60, right? Good. Okay. All right. Now, next we are going for this, that 1 over s minus 1 square, right? Okay. And we were reminded of a result. I mean, if I put such a thing on the test for you, if I did, all right, then I will first ask you to compute this for me. That is, compute that this t e to the t is Oh, 1 second. It just.
You say compute, do you mean use the definition of the function?
Oh, no, no, no. I'm saying something different. Let me just tell you what I'm saying. Okay. I will say this. See, if you, right, if I ask you to compute this, okay, that what is the Laplace transform of t times e to the t, pretty clear? Then that's how much? 1 over s minus 1 squared. You can compute it, right? Okay. So if I used it, then who this will be then? T times e to the t, right? Everybody fine on this? Okay. Raphael, you look a little anxious. You're good?
Yeah.
Oh, very good. Thank you. I know it's late in the evening, so I can't figure out, whether I'm tired or I'm losing somebody, right?
No, I'm more wondering about the next.
Okay, tell me next one. Why don't you tell me next one? No, see, look right here. See this here?
Yeah.
So, match this with this.
No, I mean the second Laplace inverse.
Which one? This one?
No. Sorry. So that I
He's talking
understand
about the second
first.
polynomial set, or whatever you would call it.
Which one? I did.
Above and
E
to
to
the
the
right.
negative 2s over 5.
Oh, this
Yeah,
one. Okay,
yeah.
I'm not that far yet. I'm still here. So help me on this first, and then we will work on this. Okay? Yeah, go ahead.
Okay, so that's e to the t.
Very good. Okay, now let's work on this guy here. Very good. Okay, thank you, Rob. Yeah. Okay, and here we are going to look at only this, right? And an advantage of wearing my glasses is this, that I could see that Jason is pointing me in right direction. He is saying that we got this in front of us, that u alpha, right, times if I have y at t minus who? Alpha, right? Everybody clear? Then this is e to the negative times s you meant here, right? And then times what? Laplace of y. Very good. Very good. So Laplace of y. Isn't that what Jason was pointing at, right? Okay. So if because this is what helped me identify this, and 1 over s minus 6, we are treating that as an offending question now. Oh, that's e to the 6t. Why, what there to ask, right? Or answer, no? Okay. So what we have is, if we look at this guy here, okay, so we have what we have, that we have to compute. I don't know why did I, okay, I didn't have to erase it. Okay. Okay. So here, okay, so there we go. So then we have e to the negative 2, right, 1 over s minus 6, right? Am I clear? Salim, are we good, sir? Sorry about that. And then what we have, and this is Laplace of who? Laplace of who? E to the 6 what? T, right? Now go ahead and then do this, match this with this, all right, and tell me what should I write then for this guy here. One moment please. Okay, and okay, you said write u2, right? One sec. I'm just writing t. I didn't write u2t there, but that's okay. Then e to the, go ahead, 6, and t transforms to what because of this? See this here? 6, go ahead.
T minus
T minus 2, very good. Okay, Raphael, you were wondering about it. How do we look here? Everybody?
Good. Looks great.
Looks great. I mean, does it?
I mean, it's completely confusing to me.
Okay, that's what I'm saying. First of all,
the u to the 2 means that that function begins at after 2.
oh yeah, that's good. That begins after 2. Yes, right. So we are, yeah, that's what that physical phenomena is. You're absolutely. So here, look here, Raphael. We took that as for granted, as from our like earlier results, right? Are we good here? Okay. Now notice, I had to get inverse Laplace of this, right? Okay. So I factored it because, e to the negative alpha s, it factors out like this here. Makes sense? And then I factored 1 over s minus 6. Are we good? And 1 over s minus 6, I recognize right away that this is Laplace of e to the 6t. It's not I, we recognize it right away. Am I imposing my opinion here, or everybody comfortable with that? Brandon? Right, Jocelyn? Okay, good. Everybody fine? Now look at this here. See this highlighted portion and this, they match, don't they? Okay. Instead of y, I have who? E to the 6t, right? Isn't it, right? Okay. And then here I have e to the negative alpha s. What I got here? E to the negative 2s, right? So my alpha becomes what? 2, right? So that's how I got this u sub 2 alpha here, and you're absolutely right that this will be turned on after 2, okay? But we are not going that far in here, okay? All right. And then when we had e to the t here, whatever function we get, we will change t to t minus alpha, right? So here I changed it to t minus 2. And this is computer output. I was just checking our answer, and which appears to be good, right? Everybody fine? Slim? Okay, now Mehndi, I have a question for you. Okay. All right, let's see, because why should I do everything? Let's see who is going to give this to us. Okay. So we have L inverse, right? Okay. And then we got this. Yes. Go ahead. And who is telling this to us? Who is giving us this? Kareem, would you? Go ahead, sir. U sub 4th you meant, right? T. Good. Very good. One sec. E to the, yeah, I was going to get e to the t, but then I have to put e to the t minus 4. Everybody fine? Okay, Sadiq?
Yes.
Daniel?
Yeah.
Question?
No, I was looking for that.
Okay. Now, is there any next one? Oh, yeah, there are many of them, right? Oh, I see. I did this here. Okay, excuse me. I forgot to write this, and then I forgot to write that. But they are routine now, aren't they, right? So would it be okay if I finished it later and posted it? Okay. And I have been good on my words in this one. I will definitely post it. I mean, I have. Okay. So,